So, now for some fun stuff. In order to understand the management of any disease process, you must first know the physiology behind that organ system. It can be complicated and even boring at times, but I'll attempt to simplify it. We'll talk about the normal function today, and I'll leave the associated diseases for later. Without further ado, let us start. So, estrogen. It's mostly thought of as a female hormone, but both males and females always have both estrogen and testosterone in their systems. It's just about the relative balance of these compounds that affects the phenotype. There are three major sources of estrogen, and each produces different types of the hormone. The ovaries produce estradiol and estrone, 2 and E1. The placenta produces estriol, E3. And adipose tissue makes estrone, E1. Of note, the names of these compounds tell you how many OH groups are in the molecule. You can see the two OH groups on this one. So, which one would this be? Exactly, estradiol. It's not required for you to know the structure, but do understand that all steroids have this basic 4-ring structure. Now, estradiol is more potent than estrone, which is more potent than estriol. There are 3 levels of regulation for estrogen production. First, we have the hypothalamus that releases what? Pulsatile GnRH. This will stimulate the pituitary to release FSH and LH. Constant GnRH release actually inhibits the release of FSH and LH, but more on that later. Now, LH functions on the cells of the theca interna, stimulating the conversion of cholesterol to androstenedione via desmolase. FSH works on the granulosa cells to convert androstenedione to estrogen via aromatase. Now, estrogen serves many functions in the body. It stimulates the development of genitalia and breasts, and is responsible for female fat distribution. It's also responsible for the growth of the follicles, endometrial proliferation, and increased myometrial excitability. Estrogen is involved in regulating secretion of hormones by upregulating the receptors for LH, estrogen, and progesterone. It also increases the production of serum binding proteins, including sex hormone binding globulin. Now, can you think of another function of estrogens unrelated to this organ system? That's right, bone growth would be a good answer, but I'll leave that to the MSK people. Now, do not confuse sex hormone binding globulin and androgen binding protein. Both bind androgens and estrogens, but ABP is present in the testes in men to keep testicular androgen levels high, whereas SHBG is used for system transport of androgens and progesterones. So let's look at progesterone. Like estrogens, progesterone is a steroid hormone, and it can be found in the corpus luteum, the placenta, the adrenal cortex, and the testes. The key things to know about estrogen on the boards are its functions. So, things that this could include are increasing endometrial gland secretions and spiral artery development, as you can see here. So here you have your glands that are getting bigger, and here you have your spiral arteries, which are also developing. Other things that you have to remember are decreased myometrial excitability, so the opposite of estrogen. You also have increasing body temperature, and you have negative feedback on FSH and LH. As you may know, this is known as the hormone of pregnancy, so it helps to maintain pregnancy. Like many female sex hormones, progesterone concentration waxes and wanes in cycles related to ovulation and menstruation. So can you think of when in the menstrual cycle you will see a progesterone peak? It's in the middle of the secretory phase, approximately 7 days after ovulation. Why is that important? Well, it's required to maintain the endometrial lining in preparation for implantation. But we'll get more into that later when we hit menstruation. First, let's talk about the Tanner stages. So there are 5 stages of sexual development according to Tanner. Stage 1 is childhood. Stage 2 begins when you have the appearance of pubic hair. So it's also known as pubarch. Stage 3 occurs when the pubic hair darkens and becomes curly, and the penis size and length increases in boys. So remember increased length? So at which Tanner stage does peak height velocity occur? It's Tanner 3. Stage 4, however, occurs when the penis width increases. So here you would have increase of width. You also have darker scrotal skin that appears, and there's development of the gland. In girls, the areola becomes raised, but it should be noted that there's a condition called virginal breast hypertrophy. The USMLE might present this in a question as a teenage girl with a massive breast mound under her nipple, and now she's worried because there's a family history of breast cancer. This is natural, and it will regress by Tanner stage 5. Speaking of, Tanner stage 5 is the final one, and it's adulthood, and the areola are no longer raised in women. As you probably remember firsthand, these 5 stages are a gradual process, and you can have different elements of different stages happening concurrently. Also note that for each individual, the age at which they start these stages is different, although it's usually younger at a younger age. In which gender? Females, exactly. So the menstrual cycle. It's a very important process to know for the boys, and it can be divided into 2 stages. A proliferative phase, also known as follicular, and a secretory phase, also known as luteal. These 2 stages are divided by ovulation. So during the follicular phase, estrogen stimulates endometrial proliferation. This phase can have a variable length, whereas the length of the luteal phase is always approximately what? 14 days. So, towards the end of the follicular phase, estrogen levels begin to rise 2 to 3 days before the LH surge, and then they drop, because LH is going to trigger ovulation. You have the estrogen peak here, followed by the LH peak. Now, during ovulation, LH and FSH are high, and at the same time, estrogen and progesterone levels are low. All right? This part is going to be very important. Estrogen is one of the only hormones in the body that exhibits positive feedback. So when it's going up here and you see LH going up right after it, you get the positive feedback. It only does so when? Right before ovulation. This means that instead of inhibiting LH-FSH production from the anterior pituitary, it promotes it so as to enable ovulation. Now the luteal phase, the corpus luteum develops from the ruptured follicle and begins secreting large amounts of progesterone, which is going to maintain the endometrium and increase the basal temperature. If fertilization does not occur, however, progesterone levels return to normal, which you can see here. And the corpus luteum regresses, therefore you get menstruation. The endometrium also undergoes histological changes over the course of the menstrual cycle as well. During the follicular phase, the glands in the endometrium are small, narrow, and tubular. In the luteal phase, however, they become dilated and coiled, and the whole endometrium becomes more edematous. The USMLE is known for showing a histology slide of the endometrium and asking in what phase is it in, and to make sure that you know it very well. So here we have a picture of the menstruating endometrium, and you can see here the blood over here, just showing you that stromal condensation. All right? So how long is the normal cycle length? Normally it's between 21 to 35 days. As we said earlier, the luteal phase tends to be a constant 14 days. So most of the cycle variation occurs in the proliferative/follicular phase. This variation can be due to a number of factors, including stress, infection, and diet. At the end of these 14 days, women menstruate. You can see in the image, like we said earlier, the stromal condensation in the endometrium. So, what if the cycle is longer than 35 days? Well, then that is called oligomenorrhea. All right. If the cycle is less than 21 days, then it's referred to as polymenorrhea. All right. Now, the term metrorrhagia refers to frequent but irregular menstruation, whereas the term menorrhagia refers to abnormally heavy and or long menstruation, yet still a regular cycle. So what is menometrorrhagia? Exactly, it would be heavy, irregular menstruation. So here's a clinical pearl. What is the most common cause of irregular and or heavy uterine bleeding? It would be anovulation. Because you're not getting the changeover from estrogen to progesterone. Instead, you're just getting all this unopposed estrogen that continues to build up the endometrial lining and it can't sustain itself. Therefore, you get irregular, heavy bleeding. All right, another pearl. As you might be aware, menstruation can also be accompanied by cramps, right? These are contractions of the endometrium and also mastalgia, which is breast pain, and tenderness. Now, these are actually caused by prostaglandins that are released from the secretory endometrium. So you only get these symptoms if ovulation has actually occurred. So cramping is actually a good sign, although I doubt knowing so makes up for the pain. So here's a flash quiz. Which of the menstrual cycle hormones discussed exhibits positive feedback during the follicular phase of the female reproductive cycle? You got it, it's estrogen. Now, I specifically said female here because, as we'll see later on, the male reproductive cycle does not experience any positive feedback. Alright, let's focus on oogenesis, which is the creation of oocytes. Now, this figure depicts the path from a diploid oogonium, where each female germ cell starts, to a haploid ovum in 3 polar bodies where the process ends. So primary oocytes actually begin meiosis 1 during fetal life and complete meiosis 1 just prior to ovulation, meaning that between birth and puberty, all of the primary oocytes are arrested in what phase? Prophase 1. After ovulation, the haploid secondary oocyte begins meiosis 2. Now the secondary oocyte is arrested in metaphase 2 and metaphase 2 until fertilization. Lastly, down here, you can see the polar bodies. Remember we talked about them back in embryology? Well, yep, they're back again. You remember what they are? As we had said, they're non-viable daughter cells.